This is the weather in one of its most violent moments. Hurricane Alicia, a whirling fury the size of 3 states, is sweeping out of the Gulf of Mexico and onto the shore near Galveston, Texas. Winds over 100 miles an hour, high tides, and a ferocious surf pound the coastal towns, leaving behind billions of dollars of damage. For days, the National Hurricane Center has been tracking the storm and predicting its direction and strength. They were able to warn the people of Galveston in time for them to move away from the danger areas. Hurricanes are dramatic examples of our need to predict the weather accurately. It can literally make the difference between life and death. People who study the weather are called meteorologists. They work to predict the weather every day, when there's a big storm coming, and when it's just going to be another fair weather day. We're going to visit some meteorologists to see how they go about this. This is the National Weather Service in Albany, New York. To make a forecast for their own region, these meteorologists need to know what the weather is like not just outside their own office, but at many places around the world. They need the big picture, and to get it, they use computers.
One of the tools that we use in trying to predict the weather is a computer and computer monitors. And we can display all of our weather maps, or a large number of weather maps, on these different monitors that we have over here. What we're looking at right now is an area of showers and thunder showers that pretty much surround the state of Florida. The weather changes constantly, and the main part of our job is to try to stay ahead of what's going on with the weather and to predict what's going to happen a few hours from now and even a few days from now.
Studying the weather is studying the blanket of air around the Earth, what we call the atmosphere. The atmosphere doesn't stay still, it moves. To predict what's going to happen in one place tomorrow, you have to know what's happening somewhere else today. Everyone has noticed that the air is different temperatures at different times and different places. Although that seems like a very simple idea, it's the most fundamental cause of all the things we call the weather. The air is heated by the sun, but not directly. Sunlight is changed to heat as it is absorbed by the ground. It makes the ground warm. The ground then heats the air. But the ground isn't heated to the same temperature in all places. Dark surfaces absorb more sunlight than light areas and become warmer. Light-colored areas of land absorb less heat than dark ones, and water absorbs heat more slowly than land. This means that the air over water is usually cooler during the day than the air over land. All of us have probably experienced this. It's more pleasant to be at the shore than to be in a parking lot on a hot day. But how do these differences in heating cause all different kinds of weather? Here's a place where we can find out. The Great Balloon Race. We'll be able to see what happens to air when it's heated, and that will help us to understand the weather. These balloons are simply huge bags made of special fabric. At first, big fans blow air into them. But once the balloon is partially filled, the fan is taken away and a burner is brought in. The burner heats the air expands and rises, filling the balloon and pulling it upward. Air that's warmer than the air around it moves up. Let's take another look at what happens when air is heated by the land. In this example, the air over the land will be warmer than the air over the water. It will expand and rise just as the air in the balloon did. The air over the water is cooler and denser, so it will sink and move in to push the warm air up. The result? A wind, blowing from the area of cool air to the area of warm air. Air is heated by the Earth on a global scale, too. For example, a body of air that stays over a tropical ocean for a long time will become warm and moist. It absorbs heat as it passes over the warm water. It is also warmed in another way. The sun's energy makes water evaporate into the air. Eventually, the water vapor may condense to form clouds. The process of condensing releases energy in the form of heat, and this heats the air. If it happens over a large area, a great deal of heat is transferred to the air. A large uniform body of air is called an air mass. An air mass takes on the characteristics of the land or water under it. Air over a tropical ocean will form a warm, moist air mass. Air over the polar regions will form a cool, dry air mass. But air masses don't hold still forever. Eventually, they move and collide. The boundary between two air masses is called a front, and that's where some of our most interesting weather happens. What happens at a front depends on how the air masses are moving. A cold air mass moving into an area of warm air is called a cold front. As the cold air moves in, it pushes the warm air up into colder regions. Water vapor condenses to form tall, billowing clouds. Clouds that may bring sudden, heavy showers, lightning, and thunder. This time-lapse photography shows what clouds along a cold front can look like. In most cases, a cold front moves through quickly. After the showers, cool, dry air takes its place. But in rare circumstances, a cold front can bring one of nature's most terrible events, a tornado. A warm air mass moving into an area of cooler air is called a warm front. The warm air doesn't push the cool air aside, it rides up over the top of it. Water vapor in the warm air condenses to form first high feathery clouds. Then, as it moves through your area, a blanket of low dark rain clouds. Although a cold front may move through in a matter of hours, a warm front can stick with you, a slow drizzle that may last for days. Here's what a warm front can look like. First, the high feathery clouds. Then, lower and lower layers of the flat dark clouds that can mean rain. Fronts don't usually stay in one place. They move. If you look at the weather map in a newspaper every day, you can track the progress of a front, like this cold front, across the country. By doing that, you might be able to predict what weather's coming to your area next. In fact, maps showing the movement of air masses and fronts are one of the main tools that forecasters use in predicting the weather. These maps are made by collecting observations of the temperature, humidity, wind speed, and other factors from weather stations all over the world. They use pictures of the weather taken from satellites and information collected from instrument packs attached to hydrogen-filled balloons. These balloons are set free to float into the upper atmosphere. But all this information doesn't add up to a surefire forecast. It still takes people to sift through the data and figure out what it means.
It can get very interesting. It's almost always interesting, but sometimes it can get very frustrating because the weather never does quite what you want it to do. The models, the computer models that we have to try to predict what's going on are not big enough. The computers that we have, even though they're the biggest computers in the country, are not big enough to include everything that's going on in the weather at any given time. That's why we're here. We're supposed to be smarter than computers and use the computers as tools, so we have to sometimes make up for the deficiencies of computers and computer programs.
Here's the forecast for Lake George, Saratoga region and the Greater Capital District. Tonight we'll see some evening clouds, then clearing skies. Overnight lows will be in the 50s. Tuesday will be sunny and pleasant with a high near 80.
The weather. Sometimes it's sunny and warm, a day to be at the beach. Other times it's rainy, windy, cold, and sometimes it's downright dangerous. All of these events are part of an intricate global system that's powered by the uneven heating of the atmosphere. Scientists have learned a lot about how this system works and how to predict the weather. But there's still much to learn. Mastering the weather is a challenge for the future.